Hello, welcome to Chapter 8. We're going to learn how to name and recognize alcohols, ethers, and thiols. So, for alcohols, we have a functional group that has the OH or hydroxyl group bonded to an sp3 hybridized carbon. What that means is that the bond angles will then have about 109 degrees. What's also interesting is that the oxygen also has an sp3 hybridization, which gives us this bent curve right here, because remember the lone pairs take up the other part of the space here. And therefore, that gives us the unique shape. Now also, not only does this oxygen have those electrons to bond to, it also has this hydrogen that can react with other things. So when we name these things, the alcohol takes precedent and becomes the name of the parent chain. So what we're going to take is the longest carbon chain that contains that OH, and then we're going to change that chain by chopping off the E and adding OL to the end of it. So if we had heptane and we have an alcohol on there, we're going to call it heptanol. Okay? When we have common names, we take the name of the alkyl group that's bonded to the oxygen and follow it by the word alcohol. Let's do some of those for example next. Okay? So in this case right here, we have ethane right here, but we have now the OH on the end, and so we cut off the E and add OL to give us ethanol. Here we have 1, 2, 3 carbons, so we have propane, cut off the E, add OL, so we have propanol. Right here, we notice we have it on this first carbon here, so we denote that it's on the 1 position, or the 1 carbon here, giving us 1 propanol. If we were to move this oxygen over 1 position, so it's on the 2 carbon, as in this one, we have to denote that as the 2 propane position, or giving us the full name of 2-propanol. When we go to something longer, like butanol right here, we again have the OH on this first carbon, so we give it 1-butanol. If we move that OH over 1 position, we have to denote it with the number 2, giving us 2-butanol. And then as we move to higher and higher, we have to just show where that is. Now, because the OH is the parent chain, we can then start numbering substituents from that position. So in this case, we have 1, 2, 3 carbons right here, meaning that our longest chain is now propane. So now that we have the OH on there, that takes this number 1 position and gives us 1-propanol. Now we have to do all of our substituents from there, giving this our 2-methyl group. So it's 2-methyl, 1-propanol. In this case here, we again have the longest chain is the propane, 1, 2, 3, and we have a methyl group and the OH both on this 2 carbon. So because the OH is on the 2 carbon, we have a 2-propanol, and we have this methyl group on the 2 carbon, so we have the 2-methyl, 2-propanol. As with other cyclic systems, the cycle takes precedent here, so we have a cyclohexane. Because we have the alcohol, we drop the E and add the OL to give us cyclohexanol. Now let's talk a little bit about the common names. Here we have what we would call an ethyl group here. So because it's the common name is the group plus alcohol, we have ethyl alcohol. Here we would have the propyl group, 1, 2, 3, so we have propyl alcohol. Now remember, when we have a propyl group, but something is not bonded to the end but bonded to the middle here, we call that the isopropyl group. So we end up with isopropyl alcohol. So we have our normal butyl alcohol, but then remember, when we have our butyl group, but something's bonded to the second carbon here, we call it sec, or sec-butyl. So in that case, this sec-butyl group is now named as an alcohol. So we have the full name of sec-butyl alcohol. This group right here is known as the isobutyl group. So we have isobutyl alcohol. And of course, the T-butyl group, gives us T-butyl alcohol. And in this case, the cyclohexyl is our substituent, so we have cyclohexyl alcohol. Okay, so we can also have compounds that have more than 1 OH on them. And when we have that, we can call them diols. So if we have 2, they're called diols. If we have 3, they're called triols. 4, tetraols, etc., etc. So when we name those, we name them for our primary group right here. So we have the ethyl group right here. So this is the ethane, but we have an OH on 1 of each of the carbons. So 1, 2 ethane diol. Here we have 1, 2 position, so we have 1, 2 propane diol. And here we have 1, 2, 3 propane triol. Now these also have common names, and they're typically called glycols if you have two groups on there. So in this case we have just the ethyl group, so we can call that the substituent ethylene. So we have ethylene glycol. Here we would have this is propylene, propylene glycol. In this case the common name is glycerol or glycerin. Okay, so now to switch gears slightly, for an alcohol we have a carbon-oxygen-hydrogen bond system. In an ether we have a carbon-oxygen-carbon bond. Okay, now the oxygen is still sp3 hybridized, which means it tries to get that 109.5 degree angle. So in all of these systems we'll see those two lone pairs there will give us a bent molecule here, but electronically we are tetrahedral. Okay, so in the naming of ethers, we take the parent alkane is the longest carbon chain, and then the substituent is the alkoxy group is the substituent. So in this case here, we have two ethyl groups, so one of them is going to be the parent, which is our longest chain, and then the other one is going to be listed as the alkoxy group. In this case, it's ethane, so the alkoxy group turns into ethoxy, ethane. So our UPAC name is ethoxyethane. In this case here, we have 1, 2, 3 carbons as our longest chain. We have a methyl group on that 2 carbon, and we have a methoxy group on that 2 carbon. So our final name is 2-methyl 2-methoxy propane. In the case of our last system here, this cyclohexanol is our parent right here because it's the longest carbon chain. And this alkoxy group is our substituent. So we're naming it 2-ethoxy cyclohexanol. And then of course we have to correctly assign our R and S's on the 2 stereo centers. When we name ethers, we also have cyclic ethers to worry about. For example, in the case of this is our smallest cyclic ether, we have 2 carbons, which is ethylene, and therefore we call it ethylene oxide. Another common ether is this compound right here, which is tetrahydrofuran. We have a heterocycle here. If these were double bonds, that would be called furan, and so because we're adding 4 hydrogens across there, we have tetrahydrofuran. In this case here, we have another heterocycle, or a cycle made up of more than just carbon, where we'd have a unit here. This is the 1 position, so we have 1, 2, 3, 4 dioxyalkane, so it's 1,4-dioxane. And so we can also have the 1, 3 position if we had the position here. The last group we're going to talk about is the functional group called the thiol, which is with a sulfur and hydrogen group bonded to an sp3 hybridized carbon. Just like with the alcohol system, we have lone pairs on the sulfur with a hydrogen on that sulfur. Because the sulfur is sp3 hybridized, it does have that 109.5 degree bend, or in this case, a little less than that. When we name thiols, we take the parent chain of the longest carbon chain that the SH group is on, and then we add thiol to the name of that parent name. For common names, we actually use the word mercaptan as a group such as methyl mercaptan or ethyl mercaptan. Alternatively, if you have the SH as a substituent on an otherwise already named parent compound, you have the prefix mercapto. So let's look at the compounds at the bottom here. We have an ethyl group, and so we have ethane thiol, or in common names we have the ethyl mercaptan. In the next system here, the longest carbon chain is propane, and therefore we have a thiol group at the end, but we also have a substituent of methyl group, and that's on the number 2 carbon, so we call it 2-methyl 1-propane thiol. Now in the case of the last one here, the alcohol takes precedent, and therefore it is the parent chain of ethanol, and therefore we give the SH group the designation as a substituent, and we call it 2-mercaptoethanol.